Okay, number one, David's speed was 20 miles per hour less than Gretchen's speed. Thus, David could travel 250 miles in half the time it took Gretchen to travel 700 miles. Find the speeds and times of both. So, we're looking at a uniform motion problem where I'm given both distances. So, David's going 250 miles, and I can see that Gretchen is going 700 miles. So, as soon as I see it's that kind of problem where they give me the distances, I'm going to go straight to my rate time distance chart. Put David on top and Gretchen below. And if I go ahead and fill in their distances, David's distance is 250 miles, Gretchen's is 700 miles. Alright, once I see it's the distances known, I'm going to use a variable to represent rates, a variable to represent times. If they happen to give me a specific rate or time, that's great. I'll use a variable for the other one, but usually they have relationships between the two. So if we look at the rate stuff first, David's speed was 20 miles per hour less than Gretchen's speed. So let's start with that. So if Gretchen's going some speed we don't know, David's going 20 miles per hour less than that. The other option would be to make David's speed R, then Gretchen would be 20 miles per hour faster. So take your pick. Either David's 20 slower or Gretchen's 20 faster. Either way, the relationship works. So I'm going to go with what they had up there. And the other thing says David's going half the time of Gretchen. So David's time is half that of Gretchen's. Now, here's two ways of doing it. I'll show you the way I like better, but let me show you the way I don't like better first. If David's half of Gretchen, if Gretchen's T, then David's half T. That's not the way I want to do it, because now I got to deal with fractions. Not that I can't handle it, but I prefer not to have to deal with fractions. As long as this is half as big as that, we're in good shape. So, the better way of doing this is if we make Gretchen's time 2T, half of that is 1T. That also works. We can see that that relationship is fine. David's time, T, is half as big as Gretchen's time, 2T. No fractions necessary, and that's a way of handling that. Once I get to this point, rate box is filled in, time box is filled in, distance is known. Rate times time equals distance for each line. So David's rate of R minus 20 times his time T should equal 250. So RT minus 20T is equal to 250. And Gretchen's rate times Gretchen's time is equal to Gretchen's distance. So R times 2T is equal to 700. And just like that, we get ourselves a nice little system of equations here. Looking at the red system of equations, dividing by 2 first gets me RT is equal to 350. And if RT is equal to 350, I can put a 350 right there in the black equation. So 350, I'm taking the black equation, switched RT with 350, minus 20T is equal to 250. So the black equation is this. That's the same equation, just replacing RT with its value. And the only variable left now is T, so if we move the 350 over here, changing its sign, I get negative 20T left on the left-hand side equals negative 100 on the right-hand side. Divide by negative 20 gets me T equals 5 hours. The question asks us to find the speeds and times of both. So, once I find an answer, I go back to my chart to establish what that answer represents. T equals 5 hours, that's David's time. Looking at all the other stuff I'm supposed to find, Gretchen's time, Gretchen's rate, David's rate, T is 5, so 2T is 10. R times 10 is supposed to be 700, so R must be 70, because 70 times 10 is 700. 70 minus 20 is 50. 50 times 5 is 250. So you can kind of verify that everything's supposed to happen. David's time is supposed to be half as big as Gretchen's? Check. David's speed is supposed to be 20 miles per hour less than Gretchen's? Check. David's distance is supposed to be 250. 50 times 5 is 250. Gretchen's 700. 70 times 10 is 700. All the stuff works out with those answers. So David, R equals 50 miles per hour. Time equals 5 hours. Gretchen, rate equals 70 miles per hour. Time equals 10 hours. And just like that, we have our answers to the problem. Number 2, use the relationship PV equals nRT to find the number of moles. So looking at this equation, number of moles is n. So what we don't know is the number of moles, n. Everything else we should know. So quantity of gas, when the temperature is 220 Kelvin, the temperature is T. The pressure is 5 atmospheres, pressure is P. The volume is 6 liters, I haven't used blue yet. The volume is 6 liters, volume is V, and R equals 0.0821. R is 0.0821. So everything underlined in anything but purple is what we know. What's underlined in purple, the number of moles, is what we don't know. So if I substitute all the stuff I know in, pressure of 5 atmospheres times volume of 6 liters equals number of moles, don't know, times R, 0.0821, times T, 220. The most common mistake people make once they understand what everything is, a lot of people leave that 0 off, so it's 0.0821. So be careful, decimal point there, then a 0. Be careful that happens. At this point, I would probably employ a calculator. I don't want to multiply 220 times 0.0821. While that's opening, I'll do this side, 30 equals. All right. Calculator anytime now. There we go. So I want to do 0.0821 times 220. That comes out to 18.062. N. So to get N, I simply have to divide 30 by 18.062. So 30 divided by 18.062 comes out to 1.6609. It doesn't specify how many decimal places. Let's just go 2. So N equals 1.66 moles. If I want to get really nitpicky, anything bigger than 1 is going to be moles, anything less than 1 is mole, but I'm not going to count off, leave an S off or put 1 on that's not necessary. But and 1.66 moles is the right answer to that one. Number 3, distance formula to find the distance between the points. The distance formula is simply this. Distance equals the square root of one thing squared plus the other thing squared. And the things that are being squared are the distances between the x's and the y's. X sub 1 minus x sub 2 or vice versa is how far apart the y's are. So if this is an x and this is an x, I'm supposed to find out how far it is from -4 to +4. -4 to 0 is 4 spaces, to 4 is 4 more spaces, that's a total of 8 spaces. Y sub 1 minus y sub 2 is just how far it is from one y to the other y. From -8 to -2 is 6 spaces. So that's how you find those two numbers. I always make them positive because when I square them they're positive anyway. So why put a minus sign on there? So -4 to 4 is 8 spaces, -8 to 2 is -2 is 6 spaces. And then we're going to square first, then add, and then finally take the square root. So those two points are 10 units away from each other. Number 4, graph -x plus 5 is not less than 8. So first thing, I don't want negated inequalities in an inequality problem. So I'm going to rewrite the problem. -x plus 5 is greater than or equal to 8. Trichotomy says 3 things are possible, greater than, less than, or equal to. Whatever is not is the only thing that's missing. So take away the less than, greater than, or equal to are still alive. Next thing I have to do is solve for x. I do that by first moving the 5 to this side, which gets me -x is greater than or equal to +3. And then I'm required to change the signs in order to get this to be +x. Changing of signs requires this inequality sign flips around, the equals to stays equal. So if it's equal, it stays equal. If it's not equal, it stays not equal. The greater than or less than switches direction. Supposed to graph that. It doesn't specify a domain, so I'm going to assume all real numbers. I've got a number line here. I just need to make sure -3 is there. I like to put it towards the middle. And I'm going to go, go smaller to the left, so -4, -5, -6 going to the left, -2, -1, 0 going to the right. And we're going to put a filled-in circle at -3 because of the equals to, and less than goes to the left, so we shade it off to the left. Make that arrow nice and bold. Showing goes on forever to infinity. Number 5, solve b(t) sub d minus 8t sub d equals 16, b(t) sub d plus 8t sub d is equal to 48. We have a nonlinear system since b and t sub d are being multiplied together. So my goal, when it says to solve this, I want to know what b equals, and I want to know what t sub d equals. That's my goal in this problem. Okay? And if I'm going to use elimination, which I should because the types of variables match, bt sub d's, t sub d's, and constants, I want to get rid of the one with the most letters in it. So currently, even though the 8t sub d and the negative 8t sub d are perfectly set up to eliminate, it's going to leave me two variables still in my equation. I'm going to change the top signs, negative, positive, negative. So now these objects cancel, getting rid of two variables in one swoop here. So negative bt sub d, positive bt sub d cancel. Positive 8 and positive 8 make positive 16 t sub d. Negative 16 plus 48 is 32. Divide, we get t sub d is equal to 2. Once we know that t sub d is equal to 2, I go back to the main problem. Either equation, doesn't matter which one you go to. I like the bottom one better because everything's positive. T sub d is equal to 2, so this and this both get replaced with 2. So 2 times b plus 2 times 8 is equal to 48. So 2 times b is equal to 32. Divide, we get b is equal to 16. And very important, when it says to solve, I want each individual variable evaluated. I don't want to find out what bt sub d is. I don't care about that. I want them individually listed. Number 6, another nonlinear system. This time substitution is better because the variable types don't match, x squared and y squared, x and y. So easiest way to make this happen is move the y over there, so x equals y plus 3 or 3 plus y, take your pick. X equals 3 plus y or y plus 3 is going to replace that x with y plus 3. I am replacing one object with more than one object, so the substitution goes in parentheses, and whatever's happening to x is going to happen to the substitution. So y plus 3 in parentheses squared plus y squared equals 17. If I then square the binomial, I'm going to get y squared plus 6x plus 9 plus y squared equals 17. I'm going to move the 17 over here, combine like terms. I'm going to get y squared plus y squared is 2y squared plus, and I don't know why that says 6x. 3 and y is 3y double is 6y. So actually 6y there. So 2y squared plus 6y, and then 9 minus 17 is minus 8 equals 0. And I just happen to see that everything's even, so I might reduce, so 2y squared plus 3y minus 4 equals 0. I can use the quadratic formula here, but I just happen to see that it's factorable pretty easily. Y plus 4 times y minus 1 equals 0. 4 times negative 1 makes negative 4. 4 plus negative 1 makes positive 3. And if y plus 4 times y minus 1 equals 0, that gives me y equals negative 4 and positive 1. Negative 4 plus 4 is 0. Positive 1 minus 1 is 0. So that's what y equals, and that's just part of my ordered pair. So what I know for a fact right now is y is equal to negative 4 and y is equal to positive 1. My job then is to find out what x equals. X equals whatever y is plus 3. So if I take x equals, and I've used the value of y of negative 4, negative 4 plus 3 is negative 1. If I say x equals y, which is 1, plus 3, so that means x is equal to positive 4. There's my two ordered pairs. You should expect this one to come out to nice integer answers like this one. So factoring will be possible here, but again, quadratic formula can be used too if you wish. Just know that you're going to get integer answers, so I expect you to reduce it down to those nice integers. And again, whatever y equals, x equals y plus 3, there's y plus 3, there's y plus 3, replacing the y values we found to find the x values. Number 7, we're going to simplify a power expression. The first step of power expression simplification is if you have a power to a power, you deal with that first. Everything else is just going to come along for the ride in this first step. So I'm going to leave y to the a over 3, b to the third, y to the 5a, b to the 3a alone. And I'm going to simplify this by multiplying the power times the power. This power is understood to be, in parentheses, times 3. So I'm going to multiply 3 times both pieces. I get 12a plus 6. Second step. If there's any negative powers, I might want to move them. With these algebraic ones, I probably ignore negative powers. I'll just go ahead and continue on. The next thing I'd probably deal with would be if I have the same letter happening. So the y and y on top are the same letter. Everything else, b is different than anything else on top. Y and b are different on the bottom. So in purple, I'm going to add the powers. So I'm supposed to do 12a plus 6 and add to that a over 3. And then I have b to the third power staying the same, y to the 5a staying the same, and b to the 3a staying the same. And then the final step is to divide powers by taking the top minus the bottom power for each thing. So I'm looking at my y's. I'm going to take the top power, which is 12a plus 6 plus a over 3, and subtract 5a from it. For the b's, I take the top power 3 and subtract the bottom power 3a. B is done. I can't make that any prettier. I got A, too many a's in this power for the red one, so I'm going to have to add like terms. This is a over 3, so I need a common denominator 3. I'm just going to get everything on the common denominator there. So if I were to make a common denominator for everything in this y, everything's over 3. This will be 36a over 3. That'll be 18 over 3. That's already a over 3. And that'll be minus 15a over 3. So then if I combine like terms in that numerator, 36 plus 1 is 37 minus 15 is 22. So I get 22a plus 18 all over 3. And then b to the 3 minus 3a. If this happened to divide evenly by 3, and this already does, then dividing everything by 3 would be purposeful. Since that doesn't divide by 3, leaving it as a big fraction is probably better than individually writing it out. So that'd be the best way to leave that. So number 7, there's your best answer. Number 8. Our first job is to extract the complex fraction out of the problem and simplify that complex fraction. This is the issue in that complex fraction. So times h, the common denominator, I have to multiply each piece times h then. So EH on top, HF on the first term on the bottom, and those h's cancel, so minus g. So what I have boxed off in blue here is equivalent to what I have right here. So I'm going to go back to my original problem. BC on top stays BC. D on the bottom stays D, minus stays minus, but instead of this blue box, I'm going to put in EH on top over HF minus G on the bottom. So now, this problem, which has been modified to here, is the same level this problem was. I've got perfectly fine, and a fraction inside a fraction. So my issue is this blue thing again. The least common denominator of this fraction is HF minus G. So multiply that by HF minus G, multiply this times HF minus G, and multiply this times HF minus G. So if I do the top first, BC times HF is BCHF. BC times minus G is minus BCG. On the bottom left, D times HF is DHF. D times G is minus DG. And over here, HF minus G cancels HF minus G, leaving me with minus EH. I recommended when I taught you this first was take this out, fix it, put it back in, and then fix it again. Some of you are trying to go directly from here to here without fixing it first, and a lot of people are getting the wrong answer. So take it out, fix it, put it back in, fix it again. I can't say it as many times, I can't say it enough. That's how you need to do it. People who do it that way get the right answer more often than not. People who do it the other way, they try to go directly from here to here. I seldom, if ever, see a right answer on those. Number 9. We have complex numbers in the denominator, so the multiplication of its conjugate, which is the same two objects with an opposite sign in the middle. So 2i stays 2i, minus 3 becomes plus 3. That is going to get rid of the imaginary numbers in the bottom. To multiply fractions, bottom times anything requires me to multiply the top by the same thing. In both cases, it's binomial multiplication. On top, I'm going to FOIL it. 5i times 2i, positive 5i times positive 2i is positive 10i squared. Positive 5i times positive 3 is positive 15i. Positive 2 times positive 2i is positive 4i. Positive 2 times positive 3 is positive 6. Everything's positive because everything's positive. But then, I squared is negative 1. Okay? Don't get in your head that I is the square root of negative 1, so all of a sudden some negatives have to start showing up in our problem. 15i is positive, 4i is positive because these are positive and these are positive, and the I just comes along for the ride. Once you get an I squared, that's when the negatives start showing up, so be careful of that. On the bottom, I don't have to FOIL it, I just have to do first times first. 2i times 2i, both positive, gives me positive 4i squared. And negative 3 and positive 3, opposite signs, gives me a negative 9. And down here, I also get an I squared. Positive 4i squared becomes negative 4. The outside and inside products are unnecessary because that's what I purposely did. Positive 6i minus 6i cancels, getting rid of all the imaginaries. So the I squared becomes real, the imaginaries cancel out, 9 already is real. So everything on the bottom is now real. What's left to do then is to combine like terms on top. Negative 10 plus 6 is negative 4. 15 plus 4i makes 19i. All this is over negative 13. Negative 4 and negative 9, same sign I add. In the last step with imaginaries, I like to separate into two separate fractions. Negative 4 over negative 13 is positive 4/13. Positive 19 over negative 13 is minus 19i over 13. That's how I expect your answer to be written. Number 10, solve square root of x minus 9 minus the square root of x equals 1. So first thing I would do here is move the square root of x over to the other side, creating a single object radical on the left equal to a binomial on the right. So then when I would square both sides, on the left-hand side I get rid of the radical completely, x plus 9. On the right side I have a binomial squared, so I do my shortcut for squaring a binomial. 1 squared, 2 times the product of the two objects, the second thing squared. So the square root of x squared is x. The square root of x times 2 is 2 square root of x. 1 times 1 is 1. I still have a radical, so I want to keep that where it is. I'm going to move everything else on the other side. So I'm going to get a minus x here. I'm going to get a minus 1 here. I'm going to get 8 equals 2 times the square root of x, which means 4 equals the square root of x if I divide both sides by 2 to get rid of this coefficient. Square root of x equals 4. So just like I did up here where I had square root equals something else, square root equals something else, I'm going to square both sides. Square root of x squared is x. 4 squared is 16. Once I know that x equals 16, what I have to do is put it back in the original problem to verify that it actually works. And all that means is I'm going to replace this x and this x with a 16 to see what happens. So square root minus square root is supposed to equal 1. 16 plus 9 is 25. 16 is 16. Square root of 25 is 5. Square root of 16 is 4. 5 minus 4 is 1 is true. I almost never have a problem like that where it doesn't work. So don't expect the empty set to be an answer to this. If it doesn't work, chances are you messed up. The most common mistake I see people make, square root of x equals 4, people say x equals 2, something like that. Instead of squaring both sides, they see a square root, they see a perfect square, they take a square root. So that is wrong. Square root of x equals square square, 4 squared is 16. So be careful of that. And again, expect it to work, so whatever answer you get, I would expect it to work. Number 11, system of 3 equations. We have this nice little binomial equation on the bottom. So x equals 2y is equivalent to x minus 2y is 0. And if x equals 2y, this x and this x are both 2y's. So if I do both of those substitutions there, the top equation is going to become 2 times 2y, which is 4y, plus 2y minus z is equal to 21. 3 times 2y is 6y, plus 3y, plus z is equal to 39. So if I take this system, combine my like terms here, that gets me down to 6y minus z is equal to 21 for the top. 9y plus z equals 39 for the bottom. And they were nice enough to make it so the z's cancel too here. So at this point, elimination will work very quickly. 6y plus 9y is 15y. Negative and positive z cancel. 21 plus 39 is 60. Y equals 4. I know y equals 4. I go back to one of the two equations. Take your pick. I'm going to go to the bottom. So it says 9y plus z equals 39. Again, y equals 4, so I put 4 instead of y there. 9 times 4 is 36. And 36 plus 3 is 39, so z must equal 3. And once I know that y and z right here, 2 times y is x, so x is 2 times y equals 4, so 2 times 4 is 8. We make an ordered triple, x goes first, y goes second, z goes last. Number 12, adding vectors. I want to make sure my calculator's in degrees, not radians, so I'm going to do that real quick. My first step is to convert these vectors into rectangular coordinates. And if I start with this -7 at an angle of -65 degrees, I'm going to type in my calculator -7 cosine -65 equals -7 sine of -65 equals. Signs are important. -7 and -65, notice. And that gets me -2.96i plus 6.34j. The second vector is plus 5 times the square root times the angle of 125. So if I do 5 cosine 125 equals, and 5 sine of 125 equals, we get -2.87i plus 4.10j. So now if I just add the two vectors together, these are both negative, so I add, I get -5.83i. These are both positive, so I add. So there's my answer in rectangular form. That gets you half credit on the test. To get full credit, then we have to go ahead and change back to rectangular, to polar form. Make sure the rectangular answer is on your paper, so if your polar answer is wrong, you'll still get the half credit for having this correct. 3 steps to get polar form. R is equal to the square root of the squares of these two numbers. And when you square, you get positive anyway, so always put positives in here. Don't ever put negatives in to tempt fate. And if we type in our calculator, square root, parentheses, 5.83 squared plus 10.44 squared in parentheses equals 11.96 is the value of R. Step 2, alpha is going to be the inverse tangent of its absolute value. So again, negatives don't matter. Second over first number. So 10.44 over 5.83. So I type that in, inverse tan of 10.44 divided by 5.83. And that comes out to 60.82 degrees. And step 3, we have to establish a quadrant. And again, here's my xy axes. I'm going left for -5.83, up for 10.44. That takes me into the second quadrant. The rule for the second quadrant is theta is equal to 180 minus alpha. That'll be 119.18. So 11.96 at an angle of 119.18 degrees. This is only to find this. R and theta are the numbers we're looking for in our polar form. Number 13. Solving a quadratic equation. I notice everything's negative. The first thing I would do is make everything positive. So x squared plus 5x plus 8 equals 0. In general, if the x squared term is negative, I like it to be positive, so I'm going to change all the signs regardless of all the rest of the signs. So even if this was positive and this was positive, since that's negative, changing all the signs would be the first thing on my checklist of things to do for this problem. If I just quickly think through factoring, 1 times 8 makes 9, 2 times 8 adds to make 4. So 1 times 8 is 8 plus makes 9. So the point is I can't factor it using normal techniques. So either completing the square or the quadratic formula will be in store. I like the quadratic formula better. I go ahead and create my structure. I'm looking for 3 numbers here. A is equal to 1, B is equal to 5, and C is equal to 8. Negative B goes in front, so whatever B is, you change its sign. 2 times A goes in the bottom. 2 times 1 is 2. And then, if I evaluate B squared minus 4AC over here, B squared is 25, subtracted by 4 times 1 times 8. That's 25 minus 32, which is -7. And the last thing to do is to clean that up a little bit. I got a negative in my radical, which makes it a positive and an I outside. So anytime you get a minus in the radical, just take an I out. Since it's imaginary, splitting it apart is appropriate. So my best final answer here is -5/2 plus or minus the square root of 7 over 2i. Square root of 7 doesn't simplify any further. If it did, you should, but it doesn't, so that's the end. Number 14, 174 milliliters per second. So first of all, we create the correct structure of our object we're converting. We have to convert to cubic inches per minute. So we have two conversions happening here. Our first conversion is changing seconds into minutes. Let's start with that because that's pretty basic. So I know that 1 minute is equal to 60 seconds. And if I look at the positioning of units, seconds is currently in the denominator. So I put seconds up in the numerator. I'm going to put minutes in the denominator. And one of these is equal to 60 of those. Second cancels second. And now I'm left with milliliters per minute. My next task is to convert from milliliters into cubic inches. And this one we have to be a little more cautious with. What I know about milliliters is that 1 milliliter is the same as 1 cubic centimeter. And I know that 1 inch is equal to 2.54 centimeters. So, what I'm going to do is I'm going to multiply by milliliters on the bottom, centimeters cubed on top. One of these equals one of these. This is milliliters, this is milliliters, so everything's exactly as it should be. All's well, everything cancels. I'm now at cubic centimeters per minute. My next conversion I'm going to use is this one. And I'm going to put centimeters on the bottom, I'm going to put inches on top, and one of these equals 2.54 of these. But notice this is cubic centimeters, this is just centimeters. Those don't match. So I do have to cube this, which is cubing the 1, cubing the inch, cubing the 2.54, cubing the centimeters. Cubic centimeters cancels. So I'm left with now inches cubed per minute, which is what I'm looking for. To get the numerical answer, I have to do 174 times 60 times 1 doesn't matter, divided by 2.54 cubed. Alright, this is the only thing being cubed because that's the only conversion that didn't work. Alright, so that's not the same as that, so I had to cube that to make it work. So I simply type that in my calculator. 174 times 60 divided by 2.54 carried 3 comes out to 637.09 inches cubed per minute. And finally, number 15, solve. This is a problem that's going to trip you up if you're not careful. The last problem on the test, and the tricky part is just the fact there's a minus sign in front of the second fraction that has multiple terms on top. I think everybody would obviously start by multiplying by 20 to get rid of the least common denominator there. So, getting rid of all the fractions. Okay, where you have to be cautious of again is that minus sign, so I'm going to really pinpoint that when I go through this. So, 20 divided by 5 is positive 4. That's being multiplied by the top, which is negative 2x minus 3. Nothing weird about that. Okay, 20 divided by 4 is 5, but it's actually attached to this minus sign. All right, so whatever this is attached to this quotient. So 20 divided by 4 is 5, but it's actually minus 5 being multiplied by 3x minus 2. And then 20 divided by 5 is 4 times 34 is 136. 136. Okay, so right here, that minus sign right there is the same as this minus sign right here, which is attached to this 5, which was the quotient of the 20 and the 4. So now when I do distributive property, 4 times each of these, it gets me negative 8x minus 12. When I do the distributive property here, I'm distributing a negative 5 through here. I get negative 15x plus 10. This plus sign is what most of you are going to mess up on if you're going to mess up on anything. So be careful. This minus, which is attached to this, is being multiplied by this. 2 negatives, when you multiply, make a positive. Be careful of that. And then what's left to do, I got a couple x objects on the left. Everything else is numbers, so I'm going to move all the numbers to the right. So minus 12 plus 10 makes minus 2. Comes over here, becomes plus 2. Negative 8x minus 15x is negative 23x. 136 plus 2 is 138. We divide both sides by negative 23. And 138 divided by negative 23 happens to equal negative 6. That'd be the correct answer to that. So be very careful that you pay attention to detail in the process as you get from fractions to non-fractions, that the distributive property happens correctly with signs. I will guarantee you the problem on the test will be the same structure as this. There will be a minus sign in front of a binomial numerator, so this type of thing is going to happen on the test. Be cautious, be watching for it.